I worked for Intel for about a little more than a year. For example, we built like a small sensor that goes on a cricket bat and watch kind of a device for pregnant women, especially in rural India. Rare earths are this set of group of elements, around 17 elements. Motor is basically made of two key elements, like what is known as the stator and the rotor. Whenever you send current onto the stator, there will be a magnetic flux. When you look at our motor, which is a synchronous reluctance motor, we have a rotor with steel laminates. Students and the parents were also with us, and he was like, you might have all heard that there are a lot of stories about electrical engineering.
99.95% of the process waste,
Yes,
but that is also radioactive.
radioactive.
Hi, this is Amrut. We are at IIT Madras, my alma mater, and India's top university for people who like to build. We are here to meet some builders, ask them, what are you building? What does it take to build? And what makes IIT Madras the best place to build? Hello and welcome to the Best Place to Build podcast. Today we're sitting with Mahalingam. He's the CTO and co-founder of Chara Chara Technologies. They make rare earth free motors. We'll learn a little bit about it. It's a damn interesting company. The idea of rare earths itself, maybe some of us knew, but thanks to Trump 2.0, all of us know it because rare earths as a commodity became a focal point for global geopolitics. So welcome to the podcast, Maha.
Yeah, hi Amrit. Thank you. Happy to be here. Thanks.
I want to start by asking you right off the bat, what are rare earths and why are they called rare earths?
Yeah. So rare earths are this set of group of elements, around 17 elements. They're at the bottom of the periodic table. From your chemistry lessons, you might know them as lanthanides and actinides. So these elements are called rare not because they're earth, not because they're actually rare. They are reasonably available when you compare it to like gold or platinum. They are not that rare, but what happens is that these elements are found in very trace quantities in the ore. So and these elements are typically having very similar atomic weight, so they are found together in most of the ore. So if you take like a ton of, for example, to compare, if you take a ton of iron ore, you will have about 500 kg to like 600 kg of iron after refining and everything. So about 50 to 60% yield. But if you take like a ton of the rare earth ore, depending on the type of metal that you want, you will end up with like 5 grams to 130, 40 grams.
Okay.
So the percentage of the element in the ore is very less. That's why.
Okay. So the metal is rare in the ore.
In the ore, yeah.
And you're saying that if iron is 50% of the ore, then these elements are
like 0.5%, 0.05%.
0.05%. Wow. Okay. So lanthanides, actinides, that's why they are rare. What are the properties of these metals that make them so interesting?
Yeah. And the other thing is that, like I mentioned, they have very similar atomic weights. So they are always found mixed together in the ore. So when you want to mine and extract them, you need to use extremely strong chemical leaching agents to separate them from each other.
Okay, you're talking about the mining and
extraction costs. And the reason why they are useful in most of the technologies, latest technology, is that because they have these very loose electrons in their outer orbit, they have very interesting properties, like for example chemical properties or magnetic properties, which make them very useful in certain key components that we use. For example, magnets, they need rare earths like neodymium, praseodymium, and dysprosium. So these rare earth elements help. For example, neodymium is one of the key elements in the most common rare earth magnet that we use, in the neodymium ferrous boron. So the magnets that you make using these rare earth components are much stronger than the magnets that, for example, you can make with standard like iron or aluminum, nickel, cobalt. So these magnets have like 3 to 4 times the magnetic strength or flux compared to the other basic magnets. So that makes them very important for magnets.
Okay, just for my, like maybe I remember it poorly, but to make a magnet, you make take the metal, put it in a shape, and then magnetize it. There's a process of magnetizing.
Yes.
It doesn't come off the ore as a magnet.
Correct. So the ore itself is not magnet. It does not have a magnetic remnant magnetic ability. You need to magnetize it. That is the same for whether you are using a ferrite based magnet or a ferrite is basically iron based magnet, or if you are a neodymium rare earth based magnet. When you make it, it is not necessarily magnetized. You use external magnetic flux to magnetize it. But there is something known as remnant flux, like how much of that magnetic flux can the magnet retain after we remove the external magnetic field. So that ability to retain the magnetism is much higher on the rare earth magnets when you compare to the non-rare earth magnets.
Understood. And is there a measure of it?
Yeah. So there is something like what we call as a Tesla. So if you look at the ferrite magnets, it's around 0.3, 0.4 Tesla. For this NdFeB magnets, around 1.4. There's another kind of rare earth magnet called samarium cobalt magnet that has around 1.2. So
Okay.
yeah,
So 2 to 3 times
2 to 3 times the
better.
Yeah.
And so your company makes motors. And can you give me a context of why are these rare earth magnets used in motors in the first place?
Right. So when you look at motors, there are various motor technologies. For example, there is
1 second. Sorry. Before that, I have to ask you, can you break down a motor for us?
Yeah. So the motor is basically made of two key elements, like what is known as the stator and the rotor. The stator is the fixed part of the motor, and the rotor is the moving or the rotating part of the motor, right? So typically there are various motor technologies. For example, induction motor or a brushless DC motor or a permanent magnet synchronous motor, or the motor technology we are working on, synchronous reluctance motor. So there is also like a brushed DC motor. So typically the stator.
All these motors have stator and rotor.
Yes.
Okay.
Yeah, the stator and rotor funda is common among all the motors, right? So if you look at the stator in almost all of these motors, they are made with a what is known as laminates, which are made with the magnetic steel and copper windings or aluminum windings that go around these laminates. So the concept is the stator by external excitation, by external current, becomes an electromagnet with varying orientation. So the way you send current through this winding or excite the windings creates an electromagnetic flux inside what is known as the. So I am talking about the most common configuration of motor, which is like a radial flux motor with a stator outside and a rotor inside. But there are other configurations, concepts are similar. So in this case, whenever you send current onto the stator, there will be a magnetic flux created inside what is known as the stator cavity, right? So now the rotor design and the components that go into the rotor determine how they interact with this flux, and that is where most of the motor technology variations come. So if you look at the BLDC or permanent magnet based EMSM motor, the rotor is again made out of steel, but they have magnets on them. So sometimes they have the magnets on the surface, or sometimes they are embedded in the rotor, depending on the various design concepts. So when you are putting current onto the stator, which creates this varying magnetic flux, and then you have magnets, permanent magnets in the rotor. So given the rotor position and the direction of this flux, so basically this you have a electromagnet in the stator and you have a magnet in the rotor. So these two magnets attract or repel each other, which produces the force in a permanent magnet motor.
So you are sort of the copper winding.
Yes.
You're pushing a magnetic flux through that.
Yes. So we are sending a current through that.
Oh, you're right. You're sending a current through that,
which produces a magnetic
flux. And that magnetic flux is sort of pushing the permanent magnet.
Yes.
In the
pushing or pulling.
Or pulling the permanent magnet in the rotor.
Yes. Which is what produces the force and produces the torque. Now, if you look at induction motor, there is another motor called induction motor. Again, the stator is the same, but the rotor is made using copper winding, which is like shorted onto itself. So now, when this copper is there inside the magnetic flux, there is an induced current in that copper, like a transformer. So now this induced current in turn produces a opposing magnetic flux. So these two magnetic fluxes interact with each other and produce the force for moving in the induction motor. And when you look at our motor, which is a synchronous reluctance motor, we have a rotor with steel laminates cut out in a particular shape. When the magnetic flux is produced by the stator, it wants to flow through the steel because steel has a lower permeability. Whereas there are regions where it is air. Air has a much higher permeability, which means that it takes more energy for the magnetic flux to flow through the air. So we will excite the stator in such a way that the rotor, because we know the rotor position, the rotor is unaligned to the magnetic flux of the stator. So that means that the magnetic flux lines coming from the flux of the stator are not matching the pattern that is on our rotor. So now the rotor wants to get aligned so that the magnetic flux lines can flow, the magnetic energy can flow through the stator steel part, right? So that is how torque is produced. So if you see why the rare earth magnets are important for
That's correct. Yeah.
So that's the question that
Yeah.
we started talking about. So sorry for the little bit of a detour. In permanent magnet motors, which are the most efficient motors that we know today, the advantage of the rare earth magnets is that because, like I mentioned, they have a much higher magnetic flux density. You are able to produce motors which has very high energy density and efficiency.
Okay.
So if you look at the other type of motor which is very common, which is the induction motor, because we are using the stator field to also induce current on the rotor. So there is always a component which is not actually doing the work, which is used for inducing the current onto the rotor. So there is always a loss component. So induction motors are typically 60 to 70% efficiency. There are some very high efficiency induction motors, but they can go up to 80, 82, not beyond that. But typically in most applications which need very high efficiency, for example, like electric mobility, there we need 90 to 93% kind of efficiency. So that is where the permanent magnet motor was like the king of the hill, because in terms of the performance.
Understood.
Yeah.
So the motor on my fan
Yes.
doesn't need to be a neodymium motor,
Yes.
rare earth motor,
Yeah.
but the motor in the EV needs to be.
Yes.
Why do EVs need to have high efficiency?
Because the efficiency of the motor is what converts the electric energy that's stored into the, basically the motor converts the electric energy that is stored in the battery into mechanical energy to do the work needed for move the vehicle. So the efficiency determines how much of the electrical energy gets converted to actual mechanical work, right? So if the efficiency is low, that means that you waste a lot of the energy. So for a given a particular size of the battery, you will be able to go for a particular what is known as a range,
Yeah.
right? So range is very important for electric vehicles.
Understood. I mean, I don't know if the relationship is linear, but it's like if it was 10% less, if the motor is 10% less efficient, then your range will be 10% less, maybe.
Yes, something like that. Correct.
Okay, which is why they all the EVs want.
The most efficient motor.
Okay. So I want to ask you here. I understood what rare earths are. I understood that these are the set of metals. I guess they go into other. Is it just this? Is it just permanent magnets, or do rare earths go into other products?
No, rare earths are used in multiple key technologies that we need today. For example, in GPS positioning systems, and in displays, and for material semiconductor processing equipment. So rare earths are significantly important for various advanced technologies that we are using today.
Understood. Yeah.
So
Maybe is the quantity, like, I know you get 5 grams per a ton, you said.
Yeah.
Is the quantity of rare earths being used in these products significantly high?
in the other products,
Yeah. Or even in motors, like how much of in a say EV vehicle, how much is the rare earth metal? I mean, how big is it, or how many grams is it?
so if you look at the cost of the motor, around 25-30% of the motor cost is the cost of the magnets.
What, really? Okay. Okay. So that's interesting.
And if you look at the magnet composition itself, 40% of the weight of the magnet, 30 to 40% is the rare earth component. However, in terms of cost wise, the rare earth will be around 90%. The other things that go into which is like iron and boron, is really cheap.
Okay. Okay. You're saying that if I take a rare earth magnet and hold it, then 40% of that is rare earth and 60% is other materials,
Yes.
other metals.
Yes.
But cost wise, 90% is the rare earth.
Yeah.
Okay. Okay. Fantastic. So now tell me, why do we all suddenly know about rare earths? What is the brouhaha about rare earths? Why is it why is it inserted itself into our lives?
Yeah. So rare earth raw material minerals are distributed unevenly around the globe, right? So there are two steps. One is that we need to mine these rare earth minerals, and second is we need to process it, refine it to get the elements out. Right now, the mines and the availability of these minerals is reasonably okay. So around, for example, China has around 60% of the available reserves, and the rest of the world has a significant amount. But when it comes to processing, refining these rare earth minerals and producing the separate individual elements and the magnets, right? So 95%, 90 to 95% is controlled by China today. So even countries like, for example, US, they have these mines where they mine the rare earth minerals, but then they ship the ore to China to get it refined and processed, and then they get the refined magnets or the refined minerals. The reason is that one is the mining process itself impacts the, basically these elements are found in the topsoil region. So as against, like, for example, copper or aluminum or
So
iron.
it's not a mine.
So it's not like a deep underground mine, right? So where, like, that's what I was going to say, like copper or iron, you follow a vein and go underground and mine it, right? Whereas rare earths are typically found in the top region of the earth's crust, right? So you end up needing to process a lot of the topsoil.
So you just have to take off kilometers of topsoil.
Right, right. And because of the percentage of availability of the rare earth in the quantity is very less. Then when it comes to the refining process, like I mentioned, we need to use extremely strong leaching agents. So they end up polluting the water, like usually the groundwater gets polluted, and there is a lot of air pollution and soil erosion. Plus, in addition to the rare earth elements, there are also radioactive elements like thorium, uranium found in the ore. So the net waste is a radioactive.
Oh, so you are generating like almost 99.95% of the processed
Yes.
as waste,
Yes,
but that is also radioactive.
radioactive, right? So this is why most countries do not want to do the refining and processing, and China is one country where it is like done prevalently, and in certain regions of China like the Bato Valley, Mongolia, these regions, there are many places where we have these cancer villages where the native fauna and people are getting cancer because of the radioactivity of the waste, right?
Oh,
So
so it's not like when you say rare earths is equally distributed, it's not like India can just set up a rare earth plant.
India
not-
can set up a rare earth plant, but it will not be like overnight. It will take like at least 5 years to a decade.
Oh,
So
plus we'll have to think of the environmental impact.
environmental
I
impact.
have to relocate people,
Yes.
all of that.
Yes, yes.
I
And
guess it must be taking a lot of energy also.
correct. Yes, it takes a lot of energy. And the other issue is that the technology needed to extract is today like with China. It's not rocket science as such, but there is a lot of work need to go into it to develop it. Similar to semiconductors, like we are getting into semiconductors the past couple of years, but it will take another 3-4 years before we produce like chips. Maybe it will take a decade before we reach like a world class level kind of thing. So if we get into rare earth extraction today as a country, it will take at least a decade or like 15 years. So China has been what you could say like guarding this technology, and they've become increasingly aggressive towards guarding. Like in the past 1 or 2 years, if you see the kind of things that they did, so first they banned the export of the rare earth extraction technology. Then they put these materials under like a regulated supply, means anywhere you ship, before you ship you need to announce like what end use is it for civilian use or military use. And they consolidated all the rare earth companies in China under like a one central government, like a conglomerate kind of thing. And most recently, as everybody is aware, when US announced some trade tariffs against China, China retaliated by stopping the supply of rare earth minerals and magnets to the everywhere in the world. So this happened, I think, like Liberation Day, like 31st of March and the first week of April. So it was, this whole thing was in the front pages. So,
But you have been talking about rare earths for many, many years, right? Like your company started in what, 2020?
so we started in 2019. Actually, we started thinking about doing something in the EV space somewhere in 2018, and we came up with this concept in early 2019, late 2018, and yeah, we registered in November 2019.
So for you, talking about rare earths to other people saying that this is what we are solving for, this must have been a very big inflection point, right?
Right.
The Liberation Day, post-Liberation Day. I don't want to call it liberation. It's a strange way of saying. Post China announcing that they will use rare earth supply as a bargaining chip, um, everybody must have woken up, and it must have been a moment in your startup
Yes.
that totally changed
Yes.
everybody's view of how.
Yeah. So actually, when we first started 2018, 2019, it was quite hard explaining why what we are doing is important, because like people had this kind of general feeling that, we get a lot of things from China. So this is one more thing that we are getting from China. So it's not like China is good or bad. We are not debating that. It is about having a single point of failure for a very key component that we need. So that's what we saw as the risk, right? And we have seen in the past that China has kind of leveraged this, for example, with Japan somewhere in 2003 or 2004. There was some kind of.
Even without the geopolitics of it, if one company is sourcing a significant raw material, which is 30% of the cost or whatever, from another company, it is susceptible to so many things, right? Even if the supply doesn't cut,
Correct.
There can be up and down in supply. There can be a price shock.
Yeah.
Suddenly, if the price goes up by 20%, then
Yeah, you're absolutely right. So one is the supply chain availability and risk. Second, geopolitics is one part of it. Then the next thing is that the price volatility. So the price of the rare earth magnets has been going up and down quite a bit in the past decade. So when we started in 2018, it was around 6K, 6,000 rupees per kg, something like that. And then it went up to 10, and then it came down to 3, 4, like that. So because China controls the whole supply chain, and they can control the pricing to set it such that they always keep the market. So that is one more aspect. So in the other aspect is that, like I mentioned, because today 90+% of our rare earth supplies are come from freshly mined and refined ores. Whereas if you compare to like aluminum or steel, more than 80-90% is recycled. So recycling of rare earth has not been happening in a significant way. So that means that it's not sustainable. So every time we need rare earth magnets, we need to mine more ore, which has a big environmental and carbon footprint. So these are all the reasons which we saw why, depending on rare earth, and we saw that the EV technology, electrification is taking off in a big way.
Okay, so when you started your company, we were not uh, concerned so much about China's dominance, but more that this is a environmentally hazardous way to do. This is more of a sustainability
And
and resilience.
supply chain resilience, and the cost. All of these aspects played into looking at alternative technologies.
Thank you. I got a context of it, but you have to explain to me what is your solution and how come your motors don't use these magnets, which you said is making the motors 90% efficient.
Yes. So to solve this, there are multiple ways. One is that other countries can start mining and refining, which now I think US is doing, India is doing, which is a good thing, because like I said, rare earth elements are not only needed for magnets, but they're needed for much other applications in defense and things like that. So that is one way. The second way is that we can come up with magnets which don't need the rare earth but still have somewhat better properties. For example, there's a company called Neuron which is doing it. They're making iron nitrate with magnets. But the solution that we thought of at Chara is that we'll make a motor technology which has the performance equivalent to permanent magnet motor. However, it does not need these rare earth magnets. So when we did our research, we came upon this technology called reluctance motors. This technology is not something new. It is probably one of the oldest motor technologies. And however, there was a lot of issues with controlling them and extracting the best performance out of that. So this is the area we thought that, if we can take this technology and refine it, apply modern manufacturing and control techniques to it, we will be able to achieve equivalent performance. So this was
okay. So this is not necessarily a new technology, but an older technology that you are improving with control. Is that what you're saying?
So synchronous reluctance motor technology is basically, at least this reluctance motor as such, is known since like late 1890s, in that time frame was the first patent was filed on this. However, there were a lot of issues with noise, vibration, power density, and controllability of this right? So noise and vibration straightforward. Like what is power density is basically for a given volume or weight of a motor, how much power output does it produce? And controllability is basically how do you make sure that the motor produces reliable output and remains, for example, the torque remains smooth throughout the operation. So these were the issues that were seen with these reluctance motors. So that's where we wanted to focus because we had a background in electronics and software, Bhakta and I. We thought that if we have a very good understanding of the motor, so that's when we found Ravi, who is our motor guru. So the three of us, we basically leveraged our knowledge in motor technology, hardware, software to optimize and improve the performance of this technology, make it perform as good or better than the permanent magnet.
Interesting. So this is like a it's like a interdisciplinary mechanical, electrical, software, all three disciplines, maybe some electronic,
Yes.
some microcontrollers coming together to form like a coherent solution.
Right, right. So there is electromagnetics, there is mechanical, there is thermal, there is electronics, and there is software. All of this working together to optimize and extract the best performance.
Yeah. A motor is not measured only on efficiency. It's also the weight density, as you're saying, and there's the thermal performance and so on. Very interesting. Thank you so much. Can I just also ask you, were you always a hardware person? Were you a core, like, in IIT we say core and non-core. Were you always a core person?
Yeah.
Was
So-
this what you wanted to do in school and college?
Yeah. So actually, kind of tinkering and playing with things like taking things apart has been something very interesting for me since like very young age. Um, However, like for example, when I cleared JE and I was getting into IIT, for some reason I was interested in joining in the computer science batch, like because that was like the top branch or something. And there was actually our batch was the first time they introduced this dual degree program, and I was thinking of taking the dual degree. I was eligible for getting dual degree computer science based on my rank. However, like some of the people advised me like we don't know what will be the value of a dual degree. So then I went for electrical engineering bachelor's. So for the first, after 1 year or so, I was a bit regretting. But then the third and fourth semester, there were some key courses and where actually we were working on the computer systems, right? So then I realized that the electrical engineering is what actually helped me to, because I liked working on system architecture, like system level, where hardware and software like interplay. So that was what was very interesting for me. So then, and I also worked on some semiconductors and power electronics during my master's. But most of my career, I worked on building embedded systems or electronics with software. So both hardware and software working together has been the core area.
Very interesting. I see your career and you worked in a bunch of startups. Of course, before Chara, you also worked at EasyTap, which is a fairly successful startup.
Yeah.
But I also see that you worked in large companies. You worked at Intel, Harman, which are both large companies. So, is this been a conscious choice of sort of mixing startup life and life in big companies? Where did you get the same amount of freedom to work on systems in both places? How has it worked for you?
Yeah. So I was very interested in working in startups from early in my career. So my first company that I worked for was a startup in New York City, where we were building like a voice and data system for a merchant navy.
Okay.
So there I was working interestingly on stepper motor control. So basically the control aspect of the stepper motor. And after that, I was working for a semiconductor company, Maxim Integrated Products. Then I came back to India in 2009 during the housing market crisis in the US. So
Post Lehman crisis.
yes. Yeah, Lehman Brothers, yes. So then I was fairly clear that I wanted to work on this kind of embedded products for startups. Right? So most of my career in India, I've been working in startup. In between, I wanted to have a like some kind of stint in a bigger company where I can learn more on the technology and the process and how like the bigger companies are like run and things like that. So that's when I worked for Intel for about a little more than a year. So there, one of the projects I worked on is the Intel had this IoT technology modules like a Curie and Galileo, and they wanted to build some kind of a reference products using this. So I was in the team that was building. For example, we built like a small sensor that goes on a cricket bat, and we built like a watch kind of a device for pregnant women, especially in rural India.
Sensor for cricket bat. So
Yeah.
this must be like for the snick, for the, what is it called? Like when it touches, when the ball touches the bat, that
Right,
kind of
right.
tech.
So basically, it is for training for batsmen.
Oh,
So basically, it is a module that detects when the ball hits the bat and the position and the stroke and things like that. So what is the is basically for the player to learn better about themselves. Now there is a startup that is doing a very similar product, and then we were working on like a bangle which rural pregnant women use. Basically, in rural India, there are a lot of air pollution because they use like coal or wood for cooking and things like that. So this is basically to monitor their health. So these kind of various products.
can I ask you a question? In an engineering life, we assume, or I don't know, maybe people have told me, I don't know if it happens to everyone. Engineers start by actually working on products, the kind of products you're describing. But as they go through their career, they go into a managerial path, or they lead teams, or they go into finance or something. Like, you have stayed an engineer throughout, right?
Yeah, right.
Has it been difficult to do that? Is it, I mean, do people get opportunities like that, or they're forced into management?
So actually, I would say that since I started working in Chara, I'm doing a bit more management related work. However, because it's my own startup, I'm still involved in the actual product and testing like that. So I would say like maybe I've been lucky. And before that, most of the roles that I worked in, it's like hands-on product development, which is what I enjoy doing as well. So that has been my focus.
I've had the good luck to meet your co-founders. Your co-founders also like that, right? They are also older engineers who have continued to remain engineers.
Right. Yes. Yeah.
It's remarkable. Really impressive. A note here I have is that you studied in electrical engineering, and electrical engineering is considered to be a really hard department. Is that true?
Um, Actually, I have a funny story. Like when we first came to, after we got the first 2 day orientation, right? So where they take us all through the campus, they take us to the library and all that. So the end of the second day, like we were all taken to our department, and then we were sitting in this one of these theater kind of classrooms, and our HOD was addressing the students, and the parents were also with us, and he was like, you might have all heard that there are a lot of stories about electrical engineering, and it's a very hard department and all, and I'm here to tell you that all the stories are true. So however, like what I would say is that the students themselves like had this mindset of like ultra competitive kind of mindset, right? So what I don't know, we used to call it like this RG kind of concept, like where I want to be the best and I will make the other person worse. So that was kind of making things harder than it needs to be. And in general, what I saw was that some of the professors had some kind of a antagonistic attitude towards the students as a group. But when you approach the professor like as an individual, a student, and if you're interested in learning, then they are super nice, right? So
Yeah.
I saw that a lot of professors, when they like talk to the students in the class, they have like this kind of a stern, you can say like kind of a villain, kind of
That
a,
is fair. The
yeah,
student community and the faculty community, maybe their missions are not fully aligned,
right.
but one student and one professor
Yes,
can definitely have a
correct.
great alignment.
Correct, correct. And when I approach many of the professors, like when I like talk to them like for doing some projects or uh, so I think things have changed a lot now. I feel like
Yeah.
nowadays the professors are like much more student friendly, and
Correct.
so that's what I have seen.
Students are also much more collaborative.
Yeah,
Just for the audience, the word RG means relative grading, which means that you're graded on a curve. So some kids get a little higher rank and some kids get a little lower rank. That, so in a very competitive environment, that causes the students to compete very strongly with each other.
and like
Especially in a,
it creates a mindset like, you know, if I need to succeed, the other guy needs to fail.
yeah,
So which is not true in the real world.
yeah,
Right.
correct.
Yeah.
I think it's changed a lot. Yeah, I see students today and projects like this car project will have 200 students working on it, and they need to succeed together.
It's changed for the better, which is
Yeah.
really nice. Yeah.
but what a memory that word RG has. Okay, so in fact, on this hard subject, I remember one of the guests here was a professor in electrical engineering, and I asked him, why is there a repetition of being a hard course? And he said very candidly that electrical engineering in general is a hard subject. There are a lot of difficult equations, a lot of things happening. And then went into a philosophical mode and he said, it's hard, that's why we do it. It's like we enjoy the hardness of the problem.
That's true. Yeah.
And looking at your career also, it feels like you've really enjoyed taking the harder route.
Right.
Your journey is your journey. You've had a particular path, but in general, how will an electrical engineer's journey be from graduating from a place like IIT to say 20 years? How will that look?
Yeah. So if somebody wants to like work in the core engineering technology domain, what I would suggest is that they probably early in their career they might want to work in some established organizations. Like don't do what I did. Like maybe early stage you want to get some real world working experience where the things are a little bit more organized, and so you can learn some processes and disciplines quite early in your career. And I think that working for a startup or doing your own startup is definitely a really good option to gain some knowledge, because when you are actually solving the hard problems which nobody has done and there is no cookbook, that's where most learning happens. So you can it is definitely a very good option for aspiring electrical engineers if they want to get into a startup. And today we are seeing that a lot of things, like for example motors, when we were studying like in the ITM, like there was an electrical machines course, and people generally looked at it with disdain, like you're like, what, motors have been around for so centuries.
Yeah, it's
Who
no
is going
longer
to,
interesting.
yeah, it's no longer interesting. But like things have come and use a whole circle.
Yeah.
Right now people are innovating in motors, people are innovating in power electronics, and then semiconductor manufacturing is coming to India in a big way. So these are all the areas I think there is going to be a lot of focus. So I think that it's a really interesting time to be in electrical.
Is it fair to say that there are more deep core jobs now than they were when we got?
Yes, I would say it's for yes.
Yeah, I do feel like if I had more opportunities to stay in core, I would have done that, but they just weren't enough. And I think the other problem was that the core jobs were not paying as well as the non-core jobs.
Right.
I think that difference has also come down.
Yeah. So I think there was, I think, an article by Tarun of Aether where he was talking about that, IITians generally are typically like overachievers, or like they want to basically shine in a field where their capability to do much more is rewarded. So historically it has been like the non-core or finance or software, things like that. But however, in the past like a decade or so, there is a lot of opportunity to be in the core area and showcase your capability.
That is fair. In fact, your company is in the middle of this deep tech resurgence that we are seeing, right? And how is it shaping up? I mean, obviously, you've been in startups for almost 10, 15 years. So, how has it changed from, say, when you were in EasyTap, which is, I guess, 10 years back?
About, yeah.
To now, in terms of how people are seeing deep tech and what you're able to achieve, the ambitions of people, and so on?
Yeah. So, one of the things that I would say changed is that maybe in the past 5 to 10 years, India has now become a market where if you develop a product that adds value, there is a market for it, right? For example, I think Mercedes-Benz, they sold India as one of their fastest growing big markets, right? So even like the most high end like luxury cars or something, there is a market for it in India. So this is something very interesting. So if you build a product which actually solves a problem and adds value, this is not only for like hardware or deep tech, anywhere in general.
Well,
so this is
that is reflective of the growing GDP per capita.
Yes. So the economy as a whole is favoring this. The second thing is that traditionally it has been like, we either import key technologies or key components. For example, if you look at the automobile sector, which was the traditional, the petrol based sector, it has been like we get the engines and most of the key components is imported either from Europe or from China or Korea, and there is no key components being developed in India. This is changing in a big way now, especially with the EV revolution. we see a big opportunity to develop the key technology. So that was one of the other motivations for starting Chara, is that we want to have these core technologies built in India, so that we can produce the best value for Indian customers and also for global customers. So this is actually
There's a demand side rise and there's a supply side
right
capability
increase
building up.
yes.
Yeah.
And we are seeing a lot of these engineers who have worked in global companies like in Europe or USA now coming back to India because they want to do something here, and also the opportunity is there. So overall, I think it's a very interesting mix.
Yeah. Some 3-4 factors have come in.
Yes.
Of course, the government is supporting it, so that's a big
Yes.
factor, right?
Yes, that's a very big factor. Government is pushing for manufacturing and core technology development through multiple incentives. Like there is a production linked incentives, and there is the DST grants, and then there is something they announced recently for
The DRI.
DRI with the ANRF funds. Yeah.
More than that, of course, that is the most important part. But in addition, you have multiple ministers talking about it in multiple forums, almost the same time as this Trump thing happened with China. This Minister Piyush Goyal had this offhand comment he made at an event saying, why are entrepreneurs making ice creams when they should be making deep tech? I think all of us just sort of like raised a hand and said, hello, look at us.
Yeah, that's true. That's true. Yeah. So what I have, I mean, slightly controversial opinion, but I have seen like in India, mostly the wealth was like with traders who are good at like buying and reselling things. And so basically it's a kind of impatient capital. Like they just want to put the money and get it out in like 30 days.
But why is that controversial? That's true across the world.
Yeah.
Across the world, the Walmarts and the Amazons who...
Well, if you see like in, for example, the US, right, most of the recent startups, people like, they are ready to be patient and, let the company build, right? Even if you say Amazon has taken like decades to reach where it is now.
Yeah, and I'm also regretting saying that because Amazon makes more money from AWS and the other things and less from the retail services.
So
and warehousing is also very tech focused.
Exactly, yeah. So they do a lot of this robotics and automation and all that in their warehouse. So basically, Amazon or Facebook, all of these are about developing new core technologies and leveraging the strength of the technology to have an unfair advantage against your competition, which is like a patient thing. It takes time, right? But they have a vision to do that. So traditionally, it has not been like that in India, but I think that in the past, I would say 20, 30 years, it is maybe like Infosys was the first company like that said, we want to focus on core technology, but still they were in a bit of a services mode. But I would still say it is like the OG startup, one of the OG startups.
Yeah, and both of us live in Bangalore, and I sometimes think about how much impact Infosys has had on a city like Bangalore. In terms of self-confidence, but also in terms of how much wealth it has spread.
Yes.
How many people have become have had access to more capital and more resources because of how much Infosys grew. Infosys has also given so much to the city, including one whole flyover.
Yes. Yep. And the metro station now. So,
yeah. Plus, the Infosys founders have set up deep tech funds, gone on to do other things, UADI, and they've set up galleries and science museums and so much, right?
Yeah.
If you are in Bangalore, you cannot miss the impact that Infosys has had on that city and on the country also.
Yes. Yeah.
The OG startup.
Yeah. So I think that people, for example, like Sridhar Vembu doing so. So these people are now showing to the country that you work on core technology, take time and build something, right? That is what will produce long-term, advantage and wealth creation. So that mindset is now becoming more prevalent, and the government is also supporting that, developing things from scratch in India. So overall, I think that this is really creating the environment for us to build on our own.
Okay, so let me recap that list. Okay, so list of items that have come together, list of forces that have come together to make this deep tech resurgence possible. You started by saying that there's a larger demand, so a product that you put out can get absorbed. Then you said supply side capabilities are building up, which is the ecosystem thing. The ecosystem is slowly compounding. I think third, we spoke about talent coming back, or the difference in salaries of deep tech jobs and say IT jobs or finance jobs is coming down. So it's lucrative for people to come individually to take that choice, saying, "Yeah, I want to work in deep tech." I think you spoke about government support, bunch of schemes, publicity also. They've made it a national mission. Um, is there some self confidence?
Yeah, and also the mindset change of the like basically the capital people with wealth.
Yeah, that is the sixth item. The capital
Is now being poured into core technology and manufacturing domains.
Nice. Six things coming together and we are here.
Yes.
I mean, it's good for IIT Madras because I think IIT Madras was always a place where research and engineering was always in focus.
Right.
I don't know why some people have said to me that maybe it's the German influence because Germans were very hard ass about engineering. So that has sort of come to us. Maybe it's because we are far from Delhi and Bombay. So we weren't thinking of e-commerce when it picked up. We weren't thinking of finance.
Yeah.
But now that the country is thinking of deep tech, we are in a good position.
Yeah, it's a very good position for IIT Madras, and I think the past 12, 15 years, like building up with the IITM Research Park and then this other Center for Innovation and all of these things, basically training a group of people who are very interested and knowledgeable in building key technologies, and that is the need of the hour for the nation. So it's fantastic.
Yeah. You have, so individually coming back to Chara, you have raised Series A from a bunch of investors recently, bunch of new money coming in. What are your plans? How are you going forward? What is, how will we see Chara 5 years from now?
Yeah. So where we are today is that we have about, our core technology has been developed and we have about 5-6 products built on this technology, which is very well proven. And we have supplied to more than 60-70 customers and we have got very good feedback and about 8 to 10 customers are scaling in a big way. And today we are shipping about hundreds of motors a month. And by March, we are planning to reach about 500 motors per month. And next year, we are planning to hit about 25K annual volume. So these are 25 to 40K. So these are the kind of a scaling plan that we are doing. And in addition to this, we are also looking at other technologies which are rare earth free. So synchronous reluctance motor, which is the core technology we are using today, is not the only rare earth free technologies. There are other rare earth free technologies that people are looking at. So we are also investing in R&D in developing new technologies. Right. So there are certain applications where the synchronous reluctance motor may not be suitable, where there is like a power density penalty of the synchronous reluctance motor compared to a PMSM motor. So there we are looking at other technologies, or there are certain applications where they need very high speed operation. So for this, we need to develop new technology. And as such, Chara is a technology core company. So we will keep looking at new technologies, keep developing new technologies. So I think about in 3 to 4 years, 5 years time, we want to have a portfolio of 20 to 30 products and working across multiple technologies. And today we are very focused on electric vehicle and some of highway applications like industrial applications or construction equipment, things like that. We want to spread into other domains as well, where anyway, see, as such, motor is like a huge application worldwide. So we want to look at other applications.
Nice. This is great. I think already some students from IIT Madras join you as interns and as employees, and some work is going on between IIT and you. I think that's going to grow, right?
Yes.
So
we are working with the industrial design department. We are working on like a kind of technology collaboration project, which we will be kicking off in January.
Nice. This is great. I think, I mean, everybody calls you Maha, so if I may. So Maha, I think what I had some 10, 15 questions, but you're so clear on your answers that all of it has got ticked off.
Okay, good.
Which is fantastic. We're doing good on time. Our time efficiency is very high.
Okay, that is good.
I want to ask you some personal questions. How has the transition to being a founder like? Are you enjoying it? Is it stressful? Is it all that it's said to be? There's this notion of running a startup, technology startup essentially, right? From outside that looks very rosy.
Yeah.
And everybody wants to be a CTO and founding CTO. But how is it actually like?
Yeah, so it has been very interesting. Actually, one of the things that I enjoy a lot is that I have a bit of a freedom to understand the situation and make my own decisions. So this has been like my personal nature as well, that I get inputs or feedback from anybody, like my parents or my like advisors, but I always like to make my own decisions. So that is something that actually working as a founder in a startup gave me a lot of freedom, and full credit to Bhakta, like even though he is more experienced, he has given me a lot of freedom to run things the way.
Your CEO.
Yeah, my CEO Bhakta. So that has been very interesting, and obviously this last 1 year has been like a kind of a roller coaster ride. So we were having some difficulty in terms of finances and trying to close the round and things like that. However, the external
The long extended arm of Trump 2.0.
yes. So Trump and Xi Jinping really helped us. I would say so. So it has been a very, very interesting year, and I think that going forward, it's going to be much more interesting. I think that this company is now in a, like what you can say, as an inflection point. So far we have been looking a lot on the technology and developing and proving out the products. Now there is no doubt that there is a need for this solution, and there is no doubt that our solution works. So these are the two things that we have kind of worked out in the past for 5-6 years, and now we have to focus a lot on execution, and we have to bring a lot of discipline in terms of the manufacturing, the supplying, quality, all of these things. So there are a lot of these new areas which has not been my area of focus in my career. Yeah. So for me also it's a lot of learning, right? So I would say two things.
Fair.
Yeah.
As a founding CTO or a founding engineering CXO, the initial problems are of getting a product ready, running the pilots, making sure you get the data and refine the product.
Yeah.
But then it quickly moves into cost optimization, manufacturability,
Yeah.
scalability, machining, tooling, supply chain management, and it's like
Yeah.
I mean exciting, right?
Yeah, it's very exciting. Yeah.
This is why we became engineers.
Correct. Yeah.
One thing I want to note though that in terms of uh, in a startup, you have all these external luck forces either giving you a boost or giving you I mean, obviously, because of this geopolitical situation, some startups have it worse.
Yeah.
They had some idea of going in, and now they have had to change.
Right.
And not just geopolitical, like this role play game, for
Right.
example, the
Yeah.
companies where the ban came in, they had to completely change their strategy overnight. For you, it worked in your favor. So,
Yes.
I mean, if it hadn't, it would have taken longer, right? But it would have happened.
Yeah. So we think that this China is like kind of like a short term, or like a, can say like a myopic view of the source of the problem. The source of the problem with the rare earths, like we discussed earlier, is the environmental impact, the sustainability.
Right.
So which is going to be like a long term negative trend. Like as electrification happens and as the demand for the high efficiency motors grow, definitely it is going to be a huge impact on the environment.
Yeah.
If we don't find alternative solutions.
Yeah.
So like you said, like this is kind of an accelerating effect and focusing effect. However, that as such, the core principles that the company is built on is going to be a long-term problem, and it's a global problem.
From a marketing lens, we say that for a particular problem, customers are sometimes customers go from problem unaware to problem aware to solution aware to brand aware.
Right.
Your customers have gone from problem unaware to solution aware in a very short accelerated time.
Right.
So it's good luck, good fortune that has shined.
Yes.
But even if it hadn't happened, that transition would have happened.
Yes.
Right?
Yeah.
And it's a foresight on your part to pick this problem almost 5 years back.
Yeah. So I would say that like full credit for that goes to my CEO Bhakta. So we were thinking that we want to do something in the EV space. Like we were looking at like battery packs or charging systems, which were like, so at that time the charging systems and the charging mechanisms had a lot of fragmentation. So we were looking into all of that, and then we saw that there are a lot of companies focusing on this battery, and especially in battery. If you want to get into the cell, it's like kind of materials problem, and it's like more like a multi-million-dollar problem. It will need a lot of capital, and not something that was core strength for us at that time. And then we were looking at the motor simultaneously, and we saw that there is scope for developing a core technology in the motor, and that's when we decided to focus on.
Damn cool. I think my questions are done. Thank you so much, Maha. I hope you like this podcast. A little different kind of technology. Many of us don't know about it, so we got to learn a little bit. Um, Please like, share, subscribe, follow Chara on their socials, follow us on our socials, and if you have questions, you can drop them in comments. We'll try to get them answered. Thank you so much.